All right, well, now here's another issue. One of the problems that we seem to have sometimes is not so much that we have a simple radical in the denominator, like a square root of 3. The problem is that we have a sum of terms in the denominator, that the denominator is not just a simple single fraction that we could multiply by. That wasn't supposed to happen. There we go. Let me just take this guy and just get rid of it. The problem that we have is, how do we get rid of that fraction? If we just multiply through by the square root of 3, we're not getting rid of anything, right? If you think about it, square root of 3 plus 2 times the square root of 3 ends up giving us another term with square root of 3 in it, right? 3 plus 2 times the square root of 3, right? That's no good. So what we have to do is we have to use something called a conjugate. And a conjugate is defined as if we have a sum of two terms, a plus b, the conjugate of that sum is going to be the difference a minus b. In other words, we always just change the operation between those two terms from addition to subtraction, or if it's subtraction, we change it to addition, and multiply that into the numerator denominator. And you think to yourself, well, why would that work? And so I want you to put your mind back into one of the special forms that we talked about. Anytime you take a plus b times a minus b, if you recall, this is a special multiplication factoring of a squared minus b squared. And if you keep that in mind, you might realize why we'd want to multiply that through in this case. So in this case, I'm going to take 2 over the square root of 3 plus 2, and I'm going to multiply in my numerator denominator by the square root of 3 minus 2 this time. This is equivalent to multiplying by 1, but we get this added bonus right here. If I take the square root of 3 plus 2, and I multiply it by the square root of 3 minus 2, verify for yourself that this is going to become, like in my special form up here, the square root of 3 squared minus 2 squared, which is to say 3 minus 2. So we're going to get 2 times the quantity square root of 3 minus 2 divided by 3 minus 2 squared is 4. So we're going to get 3 minus 4 in the denominator, and if we keep going, we're going to get 2 times the square root of 3 minus 2 divided by negative 1. That's like multiplying the numerator by negative 1 and ignoring the denominator. And we can leave the numerator in this form, or we can multiply through that negative 2 and get a negative 2 times the square root of 3 plus 4. Or if you reverse those terms, 4 minus 2 times the square root of 3 is its equivalent. Right? But you'll notice one thing that I did. I did not actually multiply through negative 2 until the very end, and that's a really good hint. If you're going to be multiplying the numerator denominator of your fraction by a constant, by a conjugate, leave that numerator in factored form until you actually need to carry out any of those multiplications and see if something will reduce then. So let's try this on another fraction, similar idea. Let's say we've got the square root of a minus the square root of 2 over the square root of a plus the square root of 2. We want to rationalize the denominator here. All right, so let's run through the steps. We would take the square root of a minus the square root of 2 in the numerator, and we need to multiply by the square root, the conjugate of the denominator. Well, the conjugate of the denominator in this particular case happens to be exactly the same as whatever you see in the numerator right now. That is the square root of a minus the square root of 2. Square root of a minus the square root of 2. So let's multiply that through. We would have to use our FOIL method up there in that numerator, unless we happen to recognize that it was this perfect square binomial, but let's go ahead and just carry it out anyways. We're going to take the square root of a squared. We're going to have minus square root of 2 times the square root of a, which is the square root of 2a, minus the square root of 2 times the square root of a, plus the square root of 2 times the square root of 2. In the denominator, since we're dealing with that special form, we're going to end up with the square root of a squared minus the square root of 2 squared. All right, so let's simplify this a little bit. Square root of a squared is just a. We've got square root of 2a and square root of 2a. We're both in subtraction, so we're going to have 2 square roots of 2a here, plus the square root of 2 squared is just 2. And in the denominator, we have a minus 2. Now, honestly, there's nothing else we can do with this expression. This is about as reduced as it's going to get. There are no common factors in the numerator and denominator. We can't cancel out the a's, or we can't cancel out the 2's because they're part of separate terms, and you can only cancel common factors, not terms. And so in this case, we're actually done. So, good luck with your homework, and I'll see you in class.